LeetCode. Problem 24. Swap nodes in pairs sounds like a quick shuffle, but it's really about pointer juggling in linked structures. Picture adjusting links between neighbors without touching their contents. It's not just a list trick. It's a glimpse into how real systems optimize pointers under pressure. And while brute force gives us traction, production demands something leaner, faster, and stack safe. So how do we swap smart without recursive chaos? All right, ducklings, let's dive in with a simple brute force splash. We'll start by swapping values between pairs. It breaks the rules, but it's a great way to understand what's happening. First, we anchor a pointer at the head to track where we are in the list. This gives us a handle to move through node pairs. We move through the list while two nodes are available, current and next. That guarantees a valid pair to work with. To swap values, we first store the current node's value, like saving a copy before overwriting. Then, we drop in the next node's value into the current node, halfway through the swap. Finally, we assign the saved value into the next node. The value exchange is now complete. With that pair done, we jump the pointer 2 steps forward, skipping the swapped pair, to look for the next set. After all pairs are processed, we hand back the head. It still leads the list, but now with values swapped between neighbors. This brute force method is big O of n in time and constant in space. Just a few local vars, but it violates the problem constraints by changing values, not links. And if nodes hold complex data, this trick falls apart. Still, it's a useful warm-up. But how can we ditch the loop entirely? Let's flip the script and let the call stack handle the swapping. Time to explore recursion. We start by checking the base cases. If the list is empty or just one node, nothing to swap. We simply return. With at least 2 nodes, we define 2 pointers, one for the first node in the pair and one for the second. To handle the rest of the list, we make a recursive call starting from the node after this pair. That gives us the swapped remainder, which we attach to the first node. Now, we link the second node to the first, completing the reversal for this current pair. Since the second node is now up front, we return it. That new head bubbles up through recursion, reassembling the swapped list. This recursive version is also big O of n in time, 1 call per node. But every call stacks up, so space is big O of n too. Clean and elegant, but risky on deep lists where stack overflow looms. Let's level up with an iterative, pointer-based solution that skips recursion and keeps space lean. We begin by adding a dummy node before the head. It simplifies edge handling, especially when the first swap starts at the head. Next, we set a pointer at the dummy node. This gives us a safe anchor to manage each swap cleanly. We loop while 2 nodes ahead are available. That keeps us safe from null pointers and avoids partial swaps. Inside the loop, we grab the next 2 nodes, our current swap pair. Keeping them local helps prevent pointer confusion. To swap, we first rewire the first node to skip over the second. Then, we point the second to the first, reversing their order. We then hook the current pointer to the second node, which now leads the swapped pair, reconnecting it to the list. After the swap, we advance the current pointer to the end of this pair. It's ready for the next round. Once all pairs are handled, we return the node after dummy, which now leads our fully swapped list. This iterative solution clocks in at big O of n time and constant space. No recursion, no stacks, no extras. It's fast, safe, and built for scale, making it ideal for interviews and production-linked list work. We kicked off by swapping values, fast but flawed. Recursion came next, clean but risky on depth. Then we landed on the iterative pointer swap. Same time, constant space. No stacks, no sneaky value swaps, just pure, efficient links. In real systems, from packet streams to job queues, you'll want that stack-free safety. That's why this pattern isn't just LeetCode friendly, it's interview grade. For a challenge, try rewriting it without a dummy node and think hard about edge cases. Keep building, keep debugging, and keep leveling up, one ducky step at a time.